Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to Calculus Craze. So we will continue our study of combinations of functions. We have already defined what do we mean by sum of two functions. We have also defined what do we mean by difference of two functions, and we have also seen what do we mean by domain of this sum and domain of this difference. So today we're going to continue towards the study of product of two functions. So we're going to study the product of two functions. Consider we have got two functions, one is f of x and other one is g of x, and we are interested in the product of these two functions, and the product of these two functions is defined by fg, multiplication. When we operate it onto some function, some variable x, we mean f of x multiplied by g of x. Okay, and the relation between the domains is going to be interesting as well, and it's not going to be different from sum and difference. So domain of f is dom f, and let's say domain of g is domain of g. This one is the domain of g and this one is the domain of f. Then the question is, what do we mean by the domain of fg, or how to find the domain of fg? It is going to be domain of f intersection with domain of g. Okay, so if we know these domains, then we just will intersect them. So this is going to be a very interesting discussion. Let's do an example. We will consider simplest kind of functions, and the nicer functions are the polynomial functions. So let me consider f of x to be x square plus 2x, and let's say my g of x is equal to, let's say, x minus 1. So you can easily trace out that the domain of f is all real numbers, and undoubtedly the domain of g is also real numbers without any doubt. So first we will define what do we mean by fg, and then we will also find out the domain of these two. So fg means the product. When we operate it onto x, we mean f of x multiplied by g of x. Okay, so our f of x is x square plus 2x and g of x is x minus 1, and when you multiply these algebraic expressions, so you get x cube minus x square plus 2x square minus 2x, which on simplification yields x cube plus x square minus 2x. So that's the product of these two functions. Now the next question that we ask is, what do we mean by, or what is the domain of this product fg? So the domain of fg is going to be domain of f intersection with domain of g, and we know that the domain of f is all of real numbers and domain of g is also, so their intersection is all real numbers, and hence you can say that the domain of the product of these two functions is again set of real numbers. Let's continue with another interesting example. So let me define first f of x. Let's say this is my f of x, which is square root x, and then we define g of x. Let's say my g of x is also square root x. Now you can easily see that the domain of this f is positive real numbers 0 to plus infinity, and the domain of g is also same, which is positive real numbers 0 till plus infinity. Okay, so now we're going to define their product. So the product fg operated onto x is equal to f of x times g of x. which is square root of x times square root of x, which on simplification gives us x. Now you might think that because this function is equal to x and this is polynomial, so every real number is in the domain. So that will be a fallacy, that will be a mistake. What you need to be careful about is the domain of this fg of x equal to x is going to be the intersection of these two domains, and because these are same, so their intersection is also going to be same. Domain of f intersection with domain of g is going to be positive real numbers. So you can see that you have a function which is equal to x, but its domain is going to be only set of positive real numbers, not the all real numbers. Indeed, I must mention that from this step to this step, your x has to be greater than equal to 0. Otherwise, you can't take this step. Let's move and take another example. Let's say I have got example number 3, where we consider f of x to be, okay, let's take 1 over 1 minus x, and let's take another function g of x, which is maybe just a square root x. So now you can see that the domain of this function is going to be, so how to find out this domain? For this domain, your 1 minus x should be greater than 0, strictly not equal to 0 even. So x should be less than 0. So the domain of f should be equal to all numbers which are less than 1, and 1 is not included. And for this, you know already that this domain of g is equal to 0 till plus infinity. Now we're going to talk about what is going to be the domain of their product. First, let's define their product fg. So it simply means you multiply f of x and g of x, which is 1 over 1 minus x times the square root x, which is going to be the square root of x over 1 minus x. Now what is going to be the domain of this function? It's not very difficult. It's going to be just intersection of these two parts. So let's take their intersection. Okay, first let me define real number line, which is from 0 to this side we have plus numbers, and this side we have numbers in minus. So let's say here we have got 1, here we have got 2, 3, so on, minus 1, maybe minus 2, minus 3, so on. Okay, so what is this set? So it's 1 and less than 1. This is going to be the set. And what about the domain of g? It is greater than equal to 0. So numbers in the g include 0. Domain of g includes 0 and positive numbers. So you can see what is going to be the intersection of these two. So this is going to be the intersection, 0 till 1, but 1 is not included. So the domain of fg is going to be the intersection of domain of f and g, which is equal to 0 included, 1 excluded. This one here. So this way you can do some other examples by yourself. Let's meet in the next video with the quotient, or the division of one function with another function. Till that, Allah Hafiz. And don't forget to subscribe, like, comment if you like the video, and share with your friends. Thank you.